Hello class 8. Today's topic is atoms, charges and electricity. You have already learned in chemistry about the atomic structure. The atom or a neutral atom contains the subatomic particles, namely the electron, proton and neutron. Electron is a negatively charged particle, a proton is a positively charged particle, and neutrons are electrically neutral particles. The nucleus, the core of the atom, contains the protons and the neutrons together, and the electrons, which are negatively charged particles, always moves around the nucleus in the orbit. So these are the orbits where the electrons revolve around the nucleus, just like the planets move around the sun. Always the number of protons and number of electrons has to be equal, so that the negative and the positive charges neutralize each other and make the atoms electrically neutral. So if the number of electron and number of protons are equal, then the atom becomes electrically neutral. But if somehow the number of proton is extra or the number of electrons are extra, then the atom becomes charged particle. When the number of electrons are extra, then the atom will be called as the negative ion. If the number of protons are extra, then the atom will be called as the positive ion. If the proton is extra, then it will develop the positive charge, and if the electrons are more than the number of electrons, then the number of protons, then the atom will have the negative charge. The number of proton cannot be taken out from the nucleus, so the number of proton cannot be added or subtracted. So it's always the electrons which moves out of the atom or can be added from some other atom to this orbit, to the external orbit, and thus there might be the increase in number of electrons or decrease in number of electrons, making the atom either the positively charged or the negatively charged ion. The like charges will repel, means the electron, if it comes closer to another electron, they being as the same charges, like charges, they will repel each other. But if the negative charge comes closer to the positive charge, then they attract each other, and this force of attraction or the force of repulsion is called as the electrostatic force. So the electrostatic force is the force by which the electrons attract the protons, or we can say the like charges attract, unlike charges attract, and the like charges repel. So this forces is because of the electrostatic force. Now let's look at the atomic structure of the element copper. So here you can see there are electrons out here. The number of protons inside the nucleus and the number of electrons outside has to be equal. Here you can see one of the electron is extra, or we can say one of the electron is alone at the outermost orbit. This orbit is the outermost orbit of the element copper, and this electron is called as the valence electron. This valence electron, which is at the outermost orbit, is free to move in any place because the force of attraction, the electrostatic force, that is the positive protons which lies in the nucleus and the electrons outside, the electrostatic force becomes weaker as the electrons move away from the nucleus, because the distance between the electron and the nucleus, as it increases, the electron will start losing its the force of attraction, and thus the outermost shell, the outermost orbit, the electrons in the outermost orbit will get less force of attraction from the nucleus. So those electrons which are closer to the nucleus, they will be attracted more, and those electrons which are away from the nucleus, away in the outermost orbit, they will have the less force of electrostatic force. So this valence electron will have very less electrostatic force, and thus it can move around freely. So these are also called as the free electrons. The free electrons, as you can see out here, this is the metal atom simply. Then these free electrons can move around freely throughout the material, throughout the body of the metal. So they move about freely inside the material, and these electrons are only the reason of carrying the charges. So we can say that these free electrons are also called as the charge carriers. If the number of charge carriers are more, then that particular element will be a good conductor, and if the number of charge carriers or the free electrons are less, then that element will be called as a bad conductor of electricity. Thus we can say that conductors have large number of free electrons, whereas insulators have less number of free electrons. Now, the free electrons, if I take only the free electrons, keeping the atoms, at its intact places within the material of the conductor, then only the free electrons, if we see, then they may be moving randomly in all possible directions. So here we can see that the electrons, the free electrons, are moving in all possible directions randomly. But as soon as the wire or the conductor is connected by some potential difference, that is in a source of electric current where there will be a negative charge and a positive charge, then since the electrons are negatively charged particles, as the negative terminal is connected at one of the end, then the electrons will move away from that particular terminal towards the positive terminal, because the like charges will repel. So from the negative terminal, because the electrons are negatively charged, they will move away and they will get attracted towards the positive terminal, because unlike charges are attract each other. So as soon as there is a potential difference, that is a negative and a positive terminal is formed because of some source of electric current, then the electrons will start moving. Instead of the random motion, they will now start moving in a particular direction, that is from the negative terminal towards the positive terminal. So the electrons will flow in from the negative towards the positive terminal, but we always take any flow from the higher potential to the lower potential. For example, if you say water flows from the higher altitude towards the lower altitude, or from high height to the low height. Okay, so similarly we can say that the current also flows from the higher terminal to the lower terminal, and by higher terminal we understand the positive terminal, and the lower terminal means the negative terminal. So from higher to lower, the current will flow from positive to negative. It's only the assumption. Actually the charge carriers are the electrons, and electrons itself are responsible for the flow of current. But conventionally we always understand that the electrons flow in particular direction, then the current will be considered as flowing in the opposite direction. So whatever is the direction, if this is the direction of electron flow, then the current will be, we will assume the current will flow in the opposite direction. So always the current will flow from the positive to the negative terminal. So as convention Okay, the direction of conventional current is opposite to the direction of the flow of electrons. Always remember that by convention we agree, throughout the throughout in all the way that the current is flowing is taken as it flows in the opposite direction, okay, compared to the direction of the electrons flow. All right, but actually it's the electrons flow by which the charges flow or the current flows.